NASA's Explorer-1, launched over 45 years ago, has recently transmitted data back to Earth that has left the scientific community in shock. Having traveled almost 14 billion miles, Explorer-1 has made a discovery so profound that it has caused the spacecraft to change its course and head back toward Earth. This revelation raises the question: could it be evidence of extraterrestrial life, an anomaly, or something even more extraordinary? The history of the Explorer missions is tied to a rare alignment of the 4 largest planets in our solar system, which occurred about 60 years ago. This alignment was first noticed by Gary Flandreau, a student working at NASA's Jet Propulsion Laboratory in 1965. Flandreau realized that the gravitational forces of these planets could be used to slingshot spacecraft on a more efficient route to explore the outer planets. This alignment would only occur once every 176 years, and to capitalize on it, NASA had to launch its spacecraft in the mid-1970s. As a result, Explorer-1 and its twin Explorer-2 were sent on an incredible mission to study the gas giants of our solar system, like Jupiter and Saturn. On September 5, 1977, Explorer-1 began its epic journey, launched aboard a Titan IIIe rocket. Just 15 days earlier, Explorer-2 had been launched. Both spacecraft aimed to explore the moons of the outer planets but ultimately ventured much farther, surpassing expectations and breaking records along the way. These spacecraft have now entered interstellar space, a completely unknown region of space, and continue to make remarkable discoveries. Explorer-1 and Explorer-2 have traveled over 12 billion miles from Earth and are still sending back groundbreaking data. Their findings have consistently surprised scientists. For example, they revealed that moons previously thought to be lifeless, such as Jupiter's Europa, are actually dynamic, with a cracked, icy surface. Explorer-2 also became the first to fly past Uranus in 1986 and Neptune a few years later, achievements no other spacecraft have matched. Despite their enormous distance from Earth, the spacecraft remain operational due to clever NASA engineering. Some non-essential parts were deactivated to save power, allowing the probes to function at least until 2030. For the engineers and scientists who have worked on these missions, the ongoing success of Explorer-1 and Explorer-2 is a bittersweet triumph. Just when it seemed their missions were winding down, Explorer-1 sent back an unexpected transmission, a discovery that has stunned the scientific world. Explorer-1's mission initially involved taking up-close pictures of Jupiter and its moons. The spacecraft captured more than 33,000 photos, revealing previously unknown details about the planet and its moons, such as Europa's fractured icy surface. After completing its primary mission, Explorer-1 used a gravitational slingshot from Jupiter to gain speed and set its course toward interstellar space. At Saturn, the two spacecraft separated. Explorer-1 passed through Saturn's rings and observed Titan, a moon surrounded by thick orange clouds. Explorer-2 continued its journey to Uranus and Neptune, where it made significant discoveries, including the identification of 10 new moons around Uranus. Tragically, the accomplishments of Explorer-2 were overshadowed by the Challenger disaster in 1986, which claimed the lives of 7 astronauts, including Krista McAuliffe, a teacher. The unexpected turn of events in Explorer-1's mission, especially the latest findings, suggests that the probe may have uncovered something truly extraordinary, potentially changing our understanding of the universe forever. Researchers and space experts have made a groundbreaking revelation about the vastness of space, highlighting the importance of gravity in our understanding of the universe. While gravity has been crucial in the development of space exploration, another essential component has played a key role in the success of missions like the Voyager probes, the Deep Space Network, DSN. Though not as glamorous as a spaceship, the DSN is incredibly vital. It functions like a massive communication system that keeps us connected with our bold space exploration efforts as they venture into the unknown. The DSN is a vast network of radio antennas spread across the globe, from California to Spain and Australia. These giant dishes, some as large as 70 meters in diameter, act as space microphones, allowing us to communicate with spacecraft far beyond Earth. So, what role does the DSN play in the Voyager missions? The Voyager probes, equipped with cameras and sensors, serve as our eyes and ears in space. To make sense of the data they send back and to guide them, we needed a powerful communication system. That's where the DSN comes in. When Voyager 1, for example, sends a message from the outer reaches of our solar system, the signal is incredibly weak, racing through space at unimaginable speeds. By the time it reaches Earth, it is almost a whisper. But the DSN's giant antennas are capable of catching these faint signals, amplifying them into usable data for scientists. The DSN is not just about receiving signals. It also sends commands to spacecraft, allowing researchers and engineers to alter the spacecraft's plans or provide precise navigation. It's like having a two-way conversation between Earth and some of the farthest human-made objects in space. One of the remarkable aspects of the DSN is its continuous, 24/7 operation. It's always listening for distant signals, ensuring constant communication with far-off probes. The DSN is more than just a network of antennas. It is the lifeline of space exploration, keeping the Voyager missions alive even as the spacecraft travel far beyond our solar system into the uncharted territories of interstellar space. The long journeys of the Voyager probes have been fraught with challenges. Voyager 1, in particular, is equipped with 3 onboard computers, including a flight data system responsible for collecting information from the spacecraft's scientific instruments. This data is transmitted to Earth in binary code, a series of ones and zeros. Recently, however, Voyager 1's flight data system appears to be stuck in a loop, repeatedly sending the same pattern of ones and zeros. This issue was first noticed on November 14 when the spacecraft's communication unit began malfunctioning. While Voyager 1 can still receive and execute commands from mission control, no new scientific or engineering data is being transmitted back to Earth. NASA engineers are working hard to restart the flight data system, but so far no usable data has been received. The team is currently investigating the root cause of the problem before deciding on the next steps, a process that could take several weeks. Interestingly, this is not the first time Voyager 1 has encountered issues with its flight data system. A similar problem occurred in 1981, but the current issue doesn't seem related to any recent malfunctions the spacecraft has experienced. As the Voyager probes face new challenges, the mission team is turning to manuals written many decades ago for guidance. While these manuals are comprehensive, they couldn't have anticipated all the obstacles the spacecraft would face as they journeyed through the universe. The team is being cautious, carefully weighing every potential consequence before sending additional commands to Voyager 1 to ensure the spacecraft's operations are not unexpectedly disrupted. Voyager 1 is so far away that it takes an astounding 22.5 hours for signals to travel from Earth to the spacecraft, and an additional 45 hours for the team to receive a response. Imagine waiting nearly 2 days just to hear back from a spacecraft. As the Voyager missions continue their epic journey through space, the team has been forced to make difficult decisions to keep them operational. They've been carefully managing the spacecraft's instruments, turning off non-essential systems to conserve power and extend the mission's lifespan. Both spacecraft have faced unexpected issues, such as a 7-month communication outage in 2020 when Voyager 2 lost contact with Earth. Fortunately, the team was able to restore communication in August by realigning the spacecraft's antenna. While the team is hopeful about restoring the flow of data from Voyager 1, the true value of these missions lies in their longevity. Scientists are eager to study how particles and magnetic fields change as the probes journey farther from the heliosphere, but this valuable data would be incomplete if Voyager 1 cannot transmit it back. The team has also been creative in finding ways to extend the power supply of both spacecraft. Despite the challenges, the Voyager missions have far exceeded their original expectations, outlasting every other spacecraft in history. While engineers continue to work tirelessly to keep them going, they know that more challenges may lie ahead. Despite their diminishing power, the Voyager spacecraft's journeys are far from over. An instructor from New Hampshire was poised to become the first non-military person to travel into space 3 years later as part of the Voyager 2 mission. Launched about 2,800 miles above Neptune's vibrant blue methane atmosphere, the spacecraft encountered the fastest winds ever recorded in our solar system, reaching speeds of up to 1,000 miles per hour. Neptune's largest moon, Triton, was discovered to be one of the coldest locations in our solar neighborhood, with surface temperatures plummeting to a staggering -235 degrees Celsius. The Moon's cryovolcanoes, which erupted nitrogen gas and fine particles up to 5 miles into its atmosphere, were another remarkable discovery. After Voyager 2's captivating images of Neptune and its moons, both spacecraft were scheduled to shut down their cameras, marking the end of their official mission. However, astronomer Carl Sagan, a member of the mission's imaging team, intervened. Despite the mission nearing its conclusion, NASA extended the mission in hopes that the spacecraft could venture into interstellar space. Renamed the Voyager Interstellar Mission, the spacecraft's journey into the unknown continued. Sagan convinced NASA to allow Voyager 1 to take one last series of images on Valentine's Day in 1990. The spacecraft turned its cameras back toward the inner solar system, capturing 60 final shots. One of these photos, famously referred to by Carl Sagan as the pale blue dot, showed Earth from a distance of 3.8 billion miles. In the image, Earth appears as a tiny speck, barely visible against the vastness of space, illuminated by a faint glimmer of sunlight reflected off the camera's optics. We have learned so much about the planets and moons in our solar system, and it's exciting to discover how unique and captivating even the farthest objects are. Voyager's journey beyond the heliosphere in August 2012 marked a significant milestone. By traveling past the heliosphere, the vast region of charged particles generated by the Sun, Voyager 1's extraordinary feat became widely recognized the following year when a study was published in the journal Science. This groundbreaking discovery was shared when Voyager 1's plasma wave instrument detected a powerful solar wind between April 9 and May 22, 2013. This event caused electrons near Voyager 1 to vibrate, indicating that the spacecraft had entered an area of higher particle density than within the heliosphere. At first glance, it seemed surprising that electron density was greater in interstellar space than near the Sun, but scientists explained that the electron density at the heliosphere's edge is much lower than that at Earth's surface. Through analysis of Voyager 1's data, scientists pinpointed the spacecraft's official entry into interstellar space on August 25, 2012. This decision was based not only on electron vibrations but also on measurements of solar particles collected by the spacecraft on that historic day, which coincidentally was the day that famed Apollo 11 astronaut Neil Armstrong passed away. On that pivotal date, Voyager 1 detected an astounding 1,000-fold decrease in solar particles and a 9% increase in cosmic rays originating from outside the solar system. These findings shed light on the dynamic and ever-changing nature of our cosmic neighborhood, illustrating the boundless and intricate nature of space exploration. Voyager 1 reached an astonishing distance of 11.25 billion miles from the Sun, approximately 121 astronomical units away. At this point, NASA's Planetary Science Division was advancing its exploration of the solar system through a variety of methods, including flybys, orbiting, landing, and sample return missions. The Voyager missions served as the pioneers, laying the groundwork for future exploration. These missions played a crucial role in studying the universe and shaping the direction of future research in planetary science, especially through the use of gravity assists, a technique that uses the mass of planets or other celestial bodies to alter the speed and trajectory of spacecraft. This method proved essential for the success of Voyager's exploration of the outer solar system.